So now we have a pitch of Soren Mouritsen of Romo Wind, one of the portfolio companies of Yellow&Blue. Welcome to Ecosummit. First the handshake and here the clicker.
Thank you. Yeah, good afternoon. It's getting late, and hopefully you haven't had too much beer yet, but so you can hear a little about Romo Wind. Romo Wind is a company focusing on optimizing wind turbines and also eventually new turbines. Right now there's 350,000 turbines out there, and just optimizing a couple of percent can easily give a market annually for 1 billion euro, so it's a very large market. Until recently, there's been a lot of focus on subsidized turbines and so on, but after the financial crisis, it's become much more important to also really have them optimized. And there you get a problem, because what Romo is addressing is the fact that they are very poor at measuring their own wind, which is absurd a bit, because wind turbines should be good at measuring wind, but because you can't measure the wind, it's also very difficult to actually monitor if a turbine performs correctly. So that also means it's difficult to actually optimize wind turbines. And we have a technology that solves this problem. So if you look here, typical what's happening at the turbine behind the rotor, you will see this wind direction sensors. They are not completely agreeing where the wind is coming from. And also the wind speed measurement, you see the wind X, is not also very uncertain on the wind measurements. And why is that? Yes, it's because all wind is being measured behind the rotor of a wind turbine. And that position, and you can see the red colors there, you have a lot of turbulence and flow distortion around the nacelle, which affects the wind measurements. So we cannot measure the wind speed. You cannot measure the input of energy in a wind turbine. You can measure the output, of course, but if you cannot measure the input, you cannot measure the efficiency or the power curve of the turbine accurately. And that turbine owners have just had to accept that, just like a car without a gas measurement device. So what we do is quite obvious, and we bought a technology from Risø, which is a very now renowned wind laboratory in Denmark. We measure the wind in front of the rotor. And we do it with some smart devices that I will show you in a moment. That is very, very simple. We stick them out from inside the spinner, and then we can measure very accurately all the wind parameters on a turbine. I will show you here a little how it works. If you look at the illustration on the right hand, when the wind is coming exactly perpendicular to the rotor, and that's how it should come in order to extract maximum energy from the wind, you will see the wind will accelerate around the spinner equally, and our small sensors, the black sensors there, will then sense the exact same wind speed. On the other hand, if the wind is coming in from an angle which is not good, that's just like a sail is not standing correctly in the wind. When the wind is coming in from an angle, it will accelerate in the right side and decelerate on the left side, just like an airplane wing. And when the rotor rotates, you will see a cyclic wind speed measurement. And the professor at Risø found out that developed some computer algorithm or mathematical algorithm that can transform this amplitude of the sinus curve into the inflow angle. So the only thing that affects the wind at the spinner is the shape of the spinner, and that's very easy to calibrate for. But the wind behind the rotor you cannot calibrate. It's very complicated turbulence, and it's impossible to really calibrate. So what we measure is what is called yaw misalignment. That is the bad inflow angle from the horizontal bad inflow angle, which is actually very disturbing for the turbine. It loses power, but it also has a lot of loads, just like a fluttering sail that can completely destroy the project economy. We can also measure all the other inflow angles, which can have very damaging effects on the turbine as well if it's in complex terrain. And we can measure the free wind speed, which is necessary in order to measure the performance of the turbine. And very importantly, last year our technology was included in the IEC standard for performance measurement of the turbine. So we believe this, for the first time, turbine owners will be able to have technology actually monitoring their expensive power plants, and therefore they can implement improvements and so on. So for the first 2 years of Romo, we spent on validating the technology, of course, and also investigating now almost 120 turbines. This is a statistic from 103 wind turbines of different brands and ages and sizes. So it was completely randomly selected. And to somewhat surprise, at least we are the first that actually quantifies it, more than half of the turbine is not pointing correctly into the wind. It is not really surprising because the turbine cannot detect it, and you only have to place the wind sensor 3 millimeters wrong, and then you get a yaw misalignment and it pointing out of the wind. And typically, a 10-degree yaw misalignment in Germany, the owner will lose about 13,000 euro annually. So that's a lot of money, and on top of that is, of course, the maintenance cost because of the loads on the turbine. So it's actually a severe problem, and the 2% we can do just by correcting the yaw misalignments is a market in the order of 500 million to 1 billion euro. So we have developed products. The first year, a couple of years we spent on just using the technology, setting it up and pulling it down again. So now we have developed these products that we have marketed here in March. The one on the left, the iSpin monitor, is a device for permanent installation. It measures all these very advanced wind parameters I was mentioning, so you can constantly interfere and intervene if there's problems with the turbine. This we sell for larger wind turbines, and we have had very large utilities already tested and validated the technology. It's Vattenfall has already stepped into their portfolio and bought the first numbers of these products. We sell them in a model where we, in a kind of Hewlett-Packard model, we sell the hardware very inexpensively. And then our bread and butter is the data monitoring, because we also see a lot of value in the data. In fact, we can see more value, perhaps even the data, in actually correcting the turbines. We see value from benchmarking other turbines. We believe we can use these data also for helping balancing the grid. As you know, wind has made a lot of disturbances in the grid. Now you have to repair on different manners. So now it's the weather forecast, and we all know the weather forecast is not so reliable. So the weather forecast is actually determining the grid, and we think these data can be used for this as well, and we can see a lot of interest along the meteorological companies and forecasting companies about this. Then we have iSpin Lite. That is just a box, a device. You drill a hole and go home and get an SMS about the yaw misalignment. You correct the turbine and go back and pull the equipment down again. So it's a very tool you just bring around to the turbine for service companies. And then finally, the sensor Sol. We are marketing to the turbine manufacturers, and we are now having 2, soon 3 turbine manufacturers who's testing it. So we have, of course, a very advanced and experienced management team. All of us have been either entrepreneurs or in this industry before. I'm myself coming from the biotech industry. I heard another company mentioning that you can actually bring some experience from one industry to another. But we have very, very seasoned people that have been in the industry for very many years. So thank you very much.
How well are you doing on revenues?
Last year we had 500,000, and we have already had 500,000 already this year. So I hope we'll taking off soon.
Yeah.
But it is of course a conservative industry. They always need to have tests and tests and tests in the backyard and prove the laws of physics again, and also in their own backyard. But that's the name of the game, and we just have to be patient.
And do you think you can make more money by retrofitting existing wind turbines, or by being embedded in new wind turbines coming to the market?
I think right now there's 320,000 turbines out there. Yeah. So there's a lot of money to be gained just by retrofitting the existing turbines. But obviously, this device should not only be used for correcting yaw misalignment, but also for much more advanced wind turbine controller that will gain a lot more power.
And what is the cost of the iSpin monitor?
The iSpin monitor, the iSpin monitor costs today about 30,000 euro. Half of that is our monitoring fees, so more or less the cost is very, very low, of course. But by reducing the cost, we can get this even lower. Cool.
Do you need more money?
Always.
Yeah.
No. Yeah. We want to. We can see this iSpin Lite in particular, because we're not hands-on. We get an SMS when the user is using it, so we can much easier give that to for instance, a service company in the United States and expand much faster than we have expected. So we would like to raise some more capital to go to the States faster, to expand our local markets. And also to make it fully compliant with the IC standard, which is very important for the industry.
Do you have a question for Soren? Quiz? Lots of wind in China, right? Talk to this gentleman afterwards.
Absolutely, yeah.
Thank you. What's the situation with the IP protection patents, and what regions might you have the technology patented?
We have an issued patent already in all relevant countries. It was invented already in 2004 by Risø, but at that time there was no really incentive in the industry to make optimal solutions, I would say. So we have still 10 years of patent coverage, but you have other patent families on top of that that can extend patent life.
What do you consider to be relevant territories? For example, North America, probably most of Europe, anywhere in Asia?
South America, North America, India, China, South Korea, entire Europe, of course.
Thank you.
Okay, thank you very much
Thank you.
once again. Thank you.